Part B. All right, so this lab will let you go through and do a SQL injection. It's nice to have a damn vulnerable web server to do them on. There's a little me on top of the big me. So how to do the SQL injections. This always ranks pretty high on, OWASP does a list of they're the Open Web Application Security Project. These guys. A nonprofit that works to improve security of software and your friends. They have local chapters all over the world, and they do like lists of the biggest deals in web vulnerabilities, and SQL injections are always pretty high up on that list. Other problems, well, actually, let's see. What are, I think they're still doing a, yeah, OWASP top 10 web application vulnerabilities. How about now?
You sound like you're like either farther away from the mic or your volume.
Oh, sorry. Our friend, the Zoom machine does that. If you're not looking.
Sounds like it's getting a little better there.
Yeah, give it a second, it'll figure it out. So this is the OWASP top 10. Let me look at audio settings. Testing 1, 2, 3. Testing 1, 2, 3.
Yeah, that sounds good.
Yeah, the automatically adjust microphone volume. Sometimes it's great, sometimes not so much.
We had somebody join in the call for a second there.
Yeah, Austin, he's probably got office hours later on. So injections, top 10 web application security risks as so outlined by OWASP. Yeah, still number 1. Injection flaws like SQL, NoSQL, OS, and LDAP injection occur when untrusted data is sent as part of a query. So if I can put my data into your code, I potentially can cause shenanigans, which is no good. There will be no shenanigans. And then hijacking a session, since session management isn't a thing that was really well thought through for websites, being able to take over a session and pretend to be somebody else is all kinds of fun. My favorite was the fire sheep that we'll talk about, but there are plenty of other session hijackings that can go on. Fire sheep's getting pretty old at this point. 2000 what? 2010, they released an extension for web browsers that let you do that. Then directory traversal is a problem when you're, well, we talked about the one for WinRAR. Similarly, anytime you let people like upload a file to your website, you know, you run the risk of, if you've ever seen that trick you can do, so this is a sample app on my web apps class. If I have a URL and I start going ... forward, it takes me back a couple of directories on the website because ... forward tells it to go up a directory. If I can do ... forward from here, I really have a problem, but luckily my Apache server is configured appropriately enough that it doesn't let you keep going. So that's directory traversal, and then CrossSite Scripting and CrossSite request forgery and clickjacking are all potentially useful to the penetration tester. So SQL injection, man, have I busted out the little Bobby tables for this class yet? You need a little XKCD in every cybersecurity class. But the famous exploits of a mom defines how these attacks work pretty well. So basically carefully crafting some sort of input so that when I push it into a web server, that input breaks out of a SQL command, because the way that folks used to do this was to put, the user's name is, $, if it's in PHP, it's almost definitely this. But the user's name would be like $username. And they'd have some query that was like select star from users, where username equals $username. But if I get $username from, if I realize that as an attacker, I can replace $username with something like, my username is going to be quote, parentheses, semicolon, which would end the SQL statement. And then I could do, my evil here. So my evil SQL statement goes after that, and then usually you comment out the rest of the SQL statement that would come after that, and voila, you've broken into something. So if you've got commercial websites, or if you're contracted, or if you're doing like a, the bug bounty for a web-facing company, these are low-hanging fruit that they're super easy to look for. So you will find those in any place where they go through and do that, any place where you take input. Like they say in the OWASPs, these occur when untrusted data is sent to the interpreter, and therefore any type of web server that's taking user input and any type of SQL database that is accepting that input is potentially on the list for things that can get hacked like that. So PHP is still running something like 70% of the internet, so a popular way to do it. And then Ruby with some Rails to put it on active server pages, or Django for Python are all ways that they, are all frameworks that you would have to be familiar enough with the language and syntax to be able to put those in there, or willing to Google the syntax for how to do SQL injection with PHP. So if you can do that, if you can inject SQL into a system, it pretty much means that you can do anything that the application can do to the database. So you can change stuff, you can potentially add a new user, you can go through and delete the database, and I think that's where exploits of a mom shows up. This is a pretty famous XKCD, at least in terms of things you will see in cybersecurity classes, where mom's son's school is having troubles because she named her son Robert, quote, or it's an apostrophe for most people, but it's the single quote, parentheses, semicolon, drop table, students, semicolon, dash dash, which is the make the rest of the statement a question. And really, admittedly, like, jokes you have to explain aren't funny, but it does nicely illustrate why you should sanitize database inputs, why you should take that stuff out of there. And there are tools inside of PHP that we teach people how to use that will go through and take out strange characters and turn them into characters that are the equivalent HTML entities. So if you've ever been to a website and you notice in the URL it's like a bunch of ampersand 20, something, something, ampersand 20, you're looking at the space converted into an HTML entity. So, whoops, characters should get escaped. You don't want people to be able to put like slashes into your code. You want to make sure that input is, again, sanitized and filtered. If there are queries that get stacked up on top of each other. If there are errors that potentially allow us to learn things about the database, it's another avenue for attack. when we talk about blind injection, it means that we can't exactly see what happens, but we know something's going on. So usually you have to go through and figure out, like based on timing, how long does it take the page to return an error if I do this versus if I do that. So it can get kind of tricky to sort of make those into useful attacks. Signature evasion attacks would be like if you have a signature for something, we get around that. If you take a SQL class, you'll learn all about unions, where you can, here is a union select statement, where we select all card numbers, like store ID 12 is what we're getting in, and I think we're injecting here. Union, select all card numbers from blah, 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 from the payment cards database. So just by unioning in that query, you can get to a bunch of database info that probably wasn't intended to be given to you. If you've got some sort of content based, so if you've got a page that will normally, so in terms of blind SQL injection, where we don't know what it is that's going on behind the wall of the web app, right? It doesn't give us some super useful like error message that says there was a problem with your SQL, which is nice if you get it. Instead, you can look for whether or not you get an error on a page. I mentioned time-based a minute ago, so if it takes, you know, if you do a database query for all of the records, even though you don't get a response back from the page that lets you know that, the fact that it took, you know, 2 minutes to return the error message as opposed to 2 seconds when you queried the entire database can be enough to let you know that something's going on. And if you really get tricky, potentially you can send the results of the query by some other protocol. And actually that guy who was doing the dependency confusion, the way he was getting a response back was by using the build servers would request a DNS name for a domain that he controlled. And this was kind of like a good guy way to make sure that he was getting a response back from these systems that A, would escape their firewalls, and B, would be easier for him to like tell the companies he was hacking into, hey, I know that we hacked into you because your servers ran code that queried this custom DNS that doesn't really exist, with the name of the system that was hacked in the query. So it's a little more advanced to get those returns out of band, but you could do the same kind of thing with a database where you would ask for, you know, my database was hacked .rows.ma. So finding those is a chore. Ideally, if you've got access to a web server that you can play around on, you want to do as much exploring as you can, and there are plenty of tools that will help you work through doing that. Tools that will, like Dirbuster, that'll go through and look for all the directories, and reverse engineering as much as you can about the code through just like the normal F12 tools. All of those things. I try to warn my students to not do this in those. We teach the first web class is JavaScript and front end, and then the second class is PHP and back end. And I just warn them like from day one, sanitizing on the client side doesn't count because you can put whatever you want inside of there. For basic SQL injection, just that tick, that single quote, will get you into, will start causing difficulties. So if you put username tick and the web page behaves differently, you know you're onto something. If you can get error messages out of it, awesome sauce. Now you would, especially if you get an error message like your SQL is incorrect, then you're off to the races. Looking at comparisons of things, putting Boolean conditions into a statement, like if you put tick or 1 equals 1 as a SQL statement. 1 generally equals 1, so you'll know that that statement evaluated as true. This should evaluate as false. See what happens. And then big queries are your friends if you're trying to blind test a database and see what goes on. Obviously, you can do the same thing for any other interpreter, like a NoSQL database or an LDAP. If you could put HTML into things, that's usually the on-ramp into doing a CrossSite Scripting type of attack, which we'll talk about in a minute here. If you're using XML, you potentially can inject XML there, and then web servers that have the ability to run code. So if there's a binary on a web server that's built to do something, or like every time PHP, or not PHP, what's the web blog thing that runs half the internet these days? Blanking on the name.
I'm not sure where you're going with it.
Oh man, there's this hugely popular, WordPress is the application I'm looking for. WordPress has like 90% of the internet runs on it these days. That's more than accurate. But whenever it has a vulnerability, like hundreds of WordPress sites, hundreds of thousands of WordPress sites get hacked all at once, and oftentimes it's because somebody managed to pull off some kind of command injection, and then they leave web shells laying around on them afterwards, after cleaning it up. So it's a big deal. Input validation is like what app developers should be doing to prevent this. So making sure that you know, the numbers you're taking in from users are appropriately sized so you don't wind up with Gandhi nuking things. That your characters are sanitized so that they're not able to sneak in things to your inputs that you don't want them to. So there are tools in every programming language that talks to the web that will take like a tick and turn it into the HTML entity that is equivalent to that. In fact, in PHP, it's called HTML entities.
Yeah, that's one of the basics I've had covered in every like programming language class I've ever taken. It's like we learned that you need to know how to do this.
Yeah, and it's super simple. Like in PHP, you've got a HTML entities that will take your input and turn them into things that are not, you know, /, you know, / tick whatever. You don't want that in your life. I'm glad that every class you've ever taken in coding has done that. It means we're getting better at it. And then anytime you should just not run user input. You know, you should do your darndest to make sure that user input is very sanitized and then only treat it as data and not as code wherever possible. Potentially, you can have injection if somebody's using HTML parameters where you've got a get or a post and you stuff into that a bunch of junk. Again, it's just a sanitizing problem to clean that up. And we've got a lab in this week's material where you can go through and do all of those injection attacks. All of that authentication and authorization we've been talking about. Those kind of attacks focus on things like weak creds that can be guessed, like mom's Wi-Fi password, or lockouts that happen if somebody's trying to brute force something. So if there are, you know, more than X number of requests, you stop letting people log in. Or sometimes a similarly appropriate solution is to make the timeout longer and longer. So if instead of immediately, you know, knocking out like your access to a system, the first time you get it wrong, it makes you wait a second. The next time you get it wrong, it makes you wait 2 seconds, and so on and so on and so on. Same thing with SQL. Oh, there it is. Open image in new tab. I guess we need to get the Gandalf meme in there too. This is basically the example of everything we're talking about. Too many failed attempts, try unlocking again in 24 hours. Like, that's exactly what you want to have happen with your web apps. Melon at 1. So if you've got injection, that's no good. If you can issue commands direct, that's another fun one. Again, a thing that shows up in a lot of CTFs. Since we have not a great way to do sessions on the web, the solution has been to use cookies that have like a session identifier in them. And oftentimes they're easy enough that you don't even need to open up the tools to find them. Bad web apps will use the URL string. So like here it's got Google search, Gandalf, password, meme, melon in it. Similarly, like poorly designed web apps will pass the session back and forth through them. And then if you can capture that cookie, you can take over that session. And you know, as far as the server is concerned, you will be that client for the remainder of it. If you can throw a redirect inside of a site, like that. So anything you see after a question mark is usually a parameter passed to the web app. And so here they've passed the redirect equals blah, blah, blah to the web app. So if it lets you go past the login page just by doing that, somebody wrote their web app bad. If you're using Kerberos authentication, or Cerberus if you're Greek, or maybe that's Roman. Anyway, it's Kerberos is the name of the thing that you use. Is that right? The three-headed dog thing.
Yep, that's Greek mythology.
The Romans steal Greek mythology and just make it their mythology.
But yeah, most of it's the same thing, just with a different name.
Right. So, Greek mythology aside, the authentication named after the three-headed dog of the netherworlds is a hugely popular way to authenticate. It's integrated into Active Directory. It's a part of the way like Windows talks to get its sessions. Those tokens that they create there are called tickets. And the idea is that unlike a session ID, your ticket can be seen on the wire without too much hassle. And the way that this happens is, and like if you ever study for a Microsoft test, you'll get to go over all of this fun stuff in the context of Active Directory, but there is an authentication server out there somewhere that gives you a ticket granting ticket that's got a list of the users and servers and then what their key is. The ticket granting service takes a look at that ticket granting ticket and says, okay, you can do this thing on this server. Usually, you know, like you can access these files, or you can use this printer, or you can, you know, all the other things that you're given authentication to in order to do that. So your client reaches out to the server, gets a list of, okay, you can go talk to the ticket granting server to get a ticket to what you need. Credentials go over there. You get your ticket back to access the resource server, and then you send over your resource to the resource server and get it back. So that's all well and good, but it does come with some downside. Potentially, if you can knock that system offline, you can either DOS the entire organization, right? Because they can't get access to anything anymore, except for the tickets they've already got sitting around, or potentially get into a place where you can compromise that. Since it's time stamped, if clocks drift And you will, if you've ever had your clock screw up on your PC, you might have noticed like all of a sudden you couldn't get to secure websites and stuff. So that's also a way you can deny service to clients if their time drifts far enough out of sync. We would have problems with people taking laptops home around like the daylight savings. Excuse me. And then they'd come back and they'd have messed with their clock manually, and then all of a sudden they can't authenticate to anything because their clock's off an hour. If you can get the password for the ticket granting account, you can make tickets that'll basically let you get into anything you want that is controlled by that. Or if you can find a service account, you can create a silver ticket that'll give you access to that particular service. IDOR hacks are insecure direct object references. If you're inputting something directly, like usernames, files, database keys, and the application doesn't check to make sure that that's what you're allowed to use, you can indirectly get to an object. We looked at directory traversal, which functions basically around that .. / operator, which you should be familiar with from just moving around a network. So right now I'm in the C:users /r directory, and if I cd ... it takes me to the previous directory, and if I cd ... again, it takes me back to a previous directory. But if I cd C:\users /r desktop ... I wind up one directory behind that. That's what gets you into trouble. And like, we had one of those vulnerabilities in 2008 on a pretty major piece of software, which is shocking. Shocking, I say. If I can trick your web server into bringing in a local file, whoops, we call that local file inclusion, where either through like directory traversal or tampering with parameters, I can get it to look at, the Etsy shadow file and show me the encrypted passwords or something. Although your web server account should not be able to access the Etsy shadow account, so maybe the Etsy password account. If I can get it to do that remotely, like sometimes PHP code will include a file from a web server. It's super common in HTML to include resources that are not on your server. In fact, if you turn on your debug tools and take a look at the network connections of your average web page, there's probably 1,000 remote requests going on at any given time to all sorts of different servers. Although not too bad. It is Google. You'd think they'd locally cache most of their stuff. Particularly things like JavaScript usually gets pulled over from some centralized repository. If you can trip those up to your own evil stuff, you're in business again. Client-side stuff, if you can get, there's an entire framework about how to take over web browsers. If you can get somebody to run your JavaScript, it's usually off to the races. I always tease my classes that your instructors have the ability to do CrossSite Scripting inside of Blackboard discussion forums, which is fun. I should do that for this class and put an alert pop-up in there or something. But if, hopefully we don't have Flash problems anymore, since that's out of circulation for the most part, or Java, which again, bad thing to be running in the browser. But any of the stuff that goes on in a web server, so any of the cookies that you can get to, trackers are a whole nother conversation. But if you can get into them, that's great. Email attachments, a hugely popular way of penetrating people's networks. So if you can modify those, attachments and make them look good, you're again in happy land for a pen tester. CrossSite or XSS, CrossSite Scripting, is where you inject code into the client side of the web browser conversation. So usually it's JavaScript, and you put JavaScript into an app. So that cross-site scripting attack would let me use the discussion forums to inject code that would potentially run on your browser. So you can do all sorts of nastiness, from reading cookies to running code to basically anything your web browser plus Java can do, or JavaScript can do, which is like a surprisingly large amount of things. So you could change the web page for sure. You could send HTTP requests to arbitrary destinations, load code into the page, all that kind of stuff. If you've given access to that page to do things, you know, turn on the microphone and the camera and start recording stuff, or potentially get into the files on the system, which can give you an opportunity to like establish persistence on a system. So lots of shenanigans can ensue. Those can go a bunch of different ways. You can have a stored cross-site script. So these persistent ones, those were usually like lots of discussion forum type boards, like www board, had all kinds of problems with this. If you can get someone to load it off of another system, we call it reflected in that case, but it's not necessarily permanently stored on that. And then you can do these things inside of the document object model, which you learn about in web apps programming, where you can make a call to a different layer of the DOM, which means it's never on the server, it's just in the memory of the browser. So that stored is usually somebody puts something into a web forum or a message board that allows you to do HTML in there, which is bad, because the most useful HTML you can do in there is like source equals link to my evil JavaScript. That's no fun. The reflected version is the victim submits some input that makes my script appear. Usually that's a link from like an email or from even like you can pull XSS off, reflected XSS, with like a URL shortener. Most of the legitimate ones are pretty good about not letting you do that. But if like I know you're logged into mybank.com and I trick you into clicking on a link that says, you know, mybank.com / give Rosema $100, you know, or whatever the whatever the code that was supposed to run when you legitimately go to do something. I can build that into a link that I put someplace. You click on that link, and then since you're authenticated to mybank.com, you know, it executes the give Rosema $100 link. Usually there are a bunch of filters on a site that will block things. So you will have to like get around those if you're going to use something like this. So depending on how they like actually implement those filters determines whether or not you'll be able to jump around on them or sidestep them. So sometimes they're just looking for things like image tags or the word image, and then you might be able to beat them by using the same kind of HTML entity encoding that they're using to try and sanitize those. Meta tags will let you put base64 encoded content on a server. And so you could potentially put, it's useful for putting like images into to forums sometimes. So you could like, when you can paste an image directly into a web form, usually what's going on is that the browser is putting a base64 encoded version of that into the web form for you. If you can do that, it means you can also do things like base64 encode JavaScript, which potentially will run after that. So another way around the kind of things that try to defend against cross-site scripting. So I think I pretty much described cross-site request forgery when we were talking about forging a request from your bank to my website, which is a hair's breadth difference than a reflected attack. But if I know you're logged into bank.com and I can get you to run commands on there, we're off and running. Clickjacking, or I don't know, as I've heard, redressing UIs is a great way to make users do stuff they're not really aware of by using the DOM to create a overlay on top of a site. I know I did this for an assignment in a class at Purdue where it was just easier to make an entire layer on top of a page than it was to try and deal with each and every different individual element on the DOM. So you just make a giant invisible layer over top of everything and collect user input through that and pass it to the rest of the app. So like you can make this a man in the middle almost. And I think those are about all the things. So now we've talked about a bunch of vulns. We'll give you some opportunity to play with them. And you'll at least be able to nag the developers that you know about what it is they should be doing when they go to develop stuff. And a high-level overview of how to do those exploits with a little side-by-side, and hopefully with a little bit of Googling, you'd be able to pull all of them off.